Hello and welcome to this film, which is all about Vsepr. And I suppose we're coming to the end now of the standard level bonding topic, and now that we've learned how to draw covalent molecules using electron dot diagrams, what we now need to start looking at is how we can use these diagrams to determine what shape the molecules will have. So in order to do that, we need to learn about this theory called Vsepr and what this theory is going to imply for covalent molecules that have these electron pairs in them. Okay, so let's start off by examining what this acronym actually stands for. Okay, so Vsepr stands for valence shell electron pair repulsion. That's not something you're ever going to be tested on, okay, but you will use it in kind of imagining what shape molecules will have. So valence shell means outer shell. So these are electron pairs that are in the valence shell or in the outer shell of the atoms. And the theory says that they'll repel each other. And when they repel each other, to minimize those repulsions, they'll try and get as far away from one another as possible. Okay, so that's what the acronym stands for. In looking at valence shell electron pairs, we need to understand that there are two different types of pairs, and we've seen these pairs in our electron dot diagrams. There are pairs which are directly involved in bonds, so that are shared between atoms, and they're called bonding pairs. And there's pairs that just belong to one atom. That's not to say dative bonds, but pairs that aren't involved in any bonds whatsoever, and they're called lone pairs or non-bonding pairs. And it's important to realise that there are different types of pairs because they'll behave differently in this electron pair repulsion theory. Now, if we imagine that the electrons in a molecule are on the surface of a sphere, so we're kind of picturing the central atom that is forming bonds with other atoms as having a spherical shape, and that the electrons that atom is sharing with other atoms are going to be kind of floating around on the surface of this sphere. So just to make that a little bit clearer perhaps, in this diagram here on the left, this atom here in the center might be bonded to some atom over here, and the bond will be between them, and the electron pair will be somewhere in between them because it's being shared between them. Okay? Likewise, we could imagine a different shape of electrons. But anyway, if we put electrons on the surface of the sphere and we said, guys, you're allowed to freely go wherever you'd like. You're going to do this because you're repelling one another and you want to minimize that. You want to lower the potential energy of the system. Okay? So if I had three pairs of electrons on the surface of a sphere, the way they'd get as far apart from one another as possible is by going to these 3 points around the equator of a sphere, okay, 120 degrees apart. Now, we can prove that if we're particularly good at geometry. We don't have to prove that in the IB chemistry course. But if you had four pairs and they're all repelling each other equally, then they'd form this shape which we'll later discover is called a tetrahedron, and the bond angle will be 109.5 degrees. So in other words, if we compared these two with one another, and I said, okay, well, if I took this shape here and put another electron pair in here, so in other words, this atom, instead of being bonded to three other atoms, was bonded to four, what effect would putting another electron pair there have? Well, it would repel these electron pairs and it would push them down. Okay, they'd be moved down to, I don't know whether you call this the Tropic of Cancer or the Tropic of Capricorn. I'm not sure if it's the same latitude either. But anyway, the point stands that if we're adding an electron pair, if you've already got some electron pairs, will affect those other electron pairs because it will repel them. Okay, so these ones will be pushed further down because they're feeling a repulsion from that pair. Okay, so that's what valence shell electron pair repulsion theory is all about. Okay, and we're going to use this to look at what shapes molecules will have by looking at how many pairs of electrons there are around the central atom and deciding what sort of geometry they'll take up in order to minimize their repulsions. Okay, so really I suppose what's in this film doesn't get tested too much. Okay, it's just an introductory film, and the next film will deal with a few different shapes and the bond angles that we'll see, and it will use this theory. As usual, if I've said anything that confused you or interested you perhaps, or you wanted to comment on, feel free to post something on YouTube. And if you don't want to do that, then come and find me in person.